So welcome to my talk about domain-driven design and strategic design through the looking glasses. This is a re-recording of the original talk to achieve better quality. So let me introduce myself. My name is Eberhard Wolff. I'm with INNOQ in Germany. We do mostly software development. I'm kind of an exception. I do mostly consulting and training. I've actually written a few books. So I wrote a book about continuous delivery, which has been translated into English. I wrote a book about microservices as an architecture approach. There is a free booklet that sums the book up. And there is also a book that talks more about technologies for microservices. And again, there is a free version that sums the book up. And my colleague Hannah Prinz and me, we wrote a book about service meshes, a new technology to do microservices, and we also translated the domain-driven design reference into German. Thankfully, Eric decided to make that book Creative Commons license, so it's actually a nice little book that you can easily translate or modify. So what I'm going to talk about is I'm going to take a look behind the mirror and see how domain-driven design actually supports us. The book Alice in Wonderland is written by Lewis Carroll. That is where the expression comes from. And actually, Lewis Carroll is also mentioned in the Blue Book as well as in the domain-driven design reference. So that is why I thought it might be a good title for this talk. This is just my experience. So I think I want to share with you what I think works in real life. Of course, your mileage might vary, so be aware of that. So let's take a look behind the mirror. First of all, let me introduce the concept of a bounded context. So I added the word ideal to it. This is what domain-driven design says is a bounded context, and it says it's a boundary within which a model and also ubiquitous language is defined and applicable. So let me give you an example of such ideal bounded context. So we are building an e-commerce system here, so we want to have something that does invoicing. Obviously, invoicing has a language, so we talk about invoices, tax rates, and customers. And we would build a domain model that also expresses this and uses these expressions. So we would have a domain model that has this ubiquitous language and implements those functionalities. We might have the calculation of taxes in there too, because it's close enough to writing invoices. So if we have that domain model, we can also use it to calculate taxes. And also if we look at the expressions and the ubiquitous language, it's actually sort of the same ubiquitous language, because again, we are talking about money, we are talking about tax rates. So it is something where we have a lot of expressions in common. And the same is true for payment. Payment is also something that has expressions that are in invoicing. However, of course, as you can see, the payment might be very complex, and in that case, we might want to separate it into a separate bounded context. So it's not really clear-cut, but for the sake of this presentation, let's assume that we are using that one single domain model for all of these functionalities. And let's call it the invoicing process. And then we have the shopping cart and the process where a shopping cart actually turns into an order, and we might call that an order process. And again, we have a ubiquitous language here. We would have a lot of expressions that talk about shopping carts and how to accept orders. And of course, this would all be turned into an order later on. And finally, there's tracking. So we want to see where our delivery is. We have the delivery algorithm that says, okay, we have a small item but valuable, like this clicker, for example. So we want to send it out and actually track it, while if we just send out the domain-driven design reference that I referred to earlier, which is not really that expensive, well, maybe we don't want to have tracking on that package and save some money, because it doesn't really matter if it is lost or not. And we want to have functionality in here that actually says, okay, if we lost the delivery, let's see where it is, and let's give the customer the ability to track it down. and that would be shipping. So again, all of these functionalities as well as the language around that would be in this one bounded context. Why would we do that? Because if a request comes into the system and it's a request that wants to see where some shipment is, well, it will be handled by shipping. If we want to see where the invoice is, whether something is paid, then it would be handled by invoicing. So chances are that most often a request to that system would be handled by just one of these bounded contexts. And changes, for example, for invoicing would be local to just invoicing. So changes will also probably be local. So that's the advantage. We have decoupled systems, and changes as well as requests will be handled by just one bounded context. And this is, of course, what we are aiming for usually. So in these bounded contexts, we would have things like an item. So if you ask me to build a system for invoicing, I would probably use an item, and I would have the price in there and the tax rate for that item. And for the order process, we would also have an item. So I can't imagine building a system that does some orders without talking about the items, but in here we would have the description and a picture to make people actually buy it. So it's a very different model from the one in invoicing. And for shipping the item, well, we probably are interested in the weight and the size of the item to figure out how to get it to the customer. So what I'm trying to say here is that in each of these bounded contexts, we will probably have the same domain object, but we will have a slightly different model for it because, well, we are interested in different properties of that domain object, sorry. And if we think about a laptop, for example, in the order process, we might be interested in the different colors the laptop might have. And actually, the system we are building, it might be it might be able to put unique pictures on the lid of each laptop. So I can have my own laptop with a picture of, I don't know, my cat on the lid. And this is something that is specific to my laptop. And of course, I want to have that laptop with that picture of my cat. But for the invoicing, it's maybe just how much RAM is in the laptop and how expensive it's going to be. So it's different. And we don't really care about the picture of the cat in there. So all the laptops that have the same price, well, they're probably the same laptop for invoicing. However, of course, they are very different if we look at the customization in the order process. And for shipping, again, maybe it doesn't really matter how much RAM is in there, how expensive they are. It's just 2 kilograms that need to be shipped to a customer. So because in each of these bounded contexts, the item is modeled differently, actually some items are considered the same. So for shipping, all the laptops are basically the same because they have the same weight and the same size. For invoicing, they are different because of the price. And for the order process, well, it's again very different because my laptop with my picture, that's the one that I'm really interested in. So I would argue for ideal bounded context, we have a ubiquitous language that is different for each of them. Of course, 2 laptops might still be the same for shipping because they have the same weight and the same size, but they might be different for invoicing because of the RAM and because of the price there. And that often leads to some confusion and to artificial terms. So if we don't have the ability to say, okay, this is the laptop for ordering, maybe we would talk about variations of a laptop, but that's really artificial. I mean, I'm talking about my laptop. I'm not talking about my variation of a laptop. So I think that is one of the reasons why this modeling is actually quite nice. But it also means that the item is only clearly defined in one idea bounded context. So I can now talk about, I can't really talk about the laptop. I have to say it's the laptop for shipping or for invoicing to make clear which one I'm actually referring to. So we end up with multiple small data models instead of one large data model that tries to cover everything. And that is one of the things that I really like about domain-driven design, because much too often I go to a customer and we figure out that there's a large complex data model that is not really changeable anymore. And that is something that domain-driven design clearly avoids and solves. So we would have simple models. And in each of these models, we might have domain objects with identical names, because I can't really build an invoicing or shipping without talking about the item that has to be invoiced or shipped. But they are really different domain objects. So for the sake of shipping, all the laptops might be the same. For the sake of invoicing, they might be slightly different. Of course, there are issues now, because we have identically named domain objects in all of these bounded contexts. And as soon as you talk about that to some person, they will actually say, well, you know, there will be redundancies and there will be inconsistencies. And that's quite scary, because as software people, we are used to the problems and the challenges that come with that, and we really want to avoid them. So let's talk about this and take a look at the example. So there's the redundant data here. So if you look at it, there's actually the price in here and the tax rate. The description here, the way is here. So it's all different data in different places, and it's not really redundant. So of course, there might be some redundant information. So for example, there might be a laptop, a ThinkPad, and we might have that name ThinkPad in all of these different bounded contexts. So there might be some redundant data, but it's not going to be a lot probably. And also, if we think about the life cycle, it might be different for each of them, because, well, invoicing, so invoices are stored for quite a long time. So maybe the laptop will still be there when we are unable to ship them. And for the order process, as soon as it can't be ordered anymore, well, it's going to not be available in the order process anymore. It might still exist in the shipping process, because the last few are shipped, even though it can't be ordered anymore. So it's actually different life cycles. So it's really, really different things that we are talking about. So I would argue that in terms of redundancy, each information, each attribute of an item belongs to one of the bounded contexts. So the price would be in invoicing, the description would be in the order process, and so on. Of course, there are some exceptions, but it's not really that bad. And if you dig deeper into the consistency issue, actually domain-driven design talks about that too. So if we talk about consistency in domain-driven design, well, first of all, we need to talk about consistency. So there is the CAP consistency, that is a theorem about distributed systems, and it basically says, do all nodes on the network see the same data? So I go to one system and ask that system about the price of a laptop, and it says it's 42 euros. And I go to another node, and that node also says 42 euros, or it gives, then they are consistent in the CAP sense. If they give different prices, 42 and 23, for example, then they are obviously not consistent. The asset consistency for transactions, that's a different thing. That basically says that the data doesn't violate any constraints. So, for example, the price of a laptop should be positive, or the order amount should be the sum of the individual order lines. Otherwise, there is something wrong there. So, how does consistency work in domain-driven design? Well, it turns out that the asset consistency is defined on the aggregate level, which is basically one large persistent object. So even if we have more than one aggregate, consistency is already not defined. So if we have a customer and an order, well, DDD basically says there is no way that you can guarantee consistency, because it's really only defined on the aggregate level. So the reason why I'm saying this is because the asset consistency is in DDD not really defined on a much more fine-grained level. It's not bounded context that might not be consistent in the asset sense, but actually parts of a bounded context an aggregate. The cap consistency, well, I would argue that replication is not really part of domain-driven design, and items are not replicated in our system because they are different in each bounded context. They have a different life cycle. So I don't think that DDD actually says anything about that. So to sum up, redundancy, well, usually if I talk about traditional models, or if I go to customers and talk about their models that they also have some redundancy. And that is not what bounded contexts are supposed to solve. So I didn't say that bounded contexts should solve the redundancy problem, but rather they should simplify the domain models. So, and the DDD doesn't even say that consistent information should be in one bounded context, that all of the bounded context should be consistent. So I would argue that you have to accept some or a few inconsistencies, and that's basically it. It's a different problem that we are trying to solve, and you should deal with the fact that there are, few inconsistencies, and you need to handle them, basically. Okay, so what about bounded context in a greenfield system? Well, without using bounded context, you will end up with very complex data models where we have hundreds of database tables and we have a lot of columns in each of them. And oftentimes it's not even possible to delete any of those columns or tables because it's not even known which part of the system uses a specific part of the database model. So a bounded context, if you use that from the start, that problem should be solved because each bounded context has its own domain model, and each bounded context would have its own database schema, of course. So there shouldn't be a problem anymore. However, usually there is already a system in place, so you have to talk about migration. So let's talk about migration. So how would you migrate towards a system that uses bounded context? Well, it might make sense to analyze existing bounded contexts that are already there and to create a context map. And the context map, the pattern in the original DDD book actually says that the context map should map existing terrain, and then you should take up some transformations. So that's what it says there in the book. So let's do that. Let's apply that concept to some existing bounded context. So here we go. So we figure out that there is a system that does the invoicing, but it also handles the orders. So that is a system that we have in our IT landscape. There is another system that is responsible for shipping out shipments to the customers, and there is a system that has all the information about items. So it's the central place where all the information about the items is stored, and we can have some kind of collaboration here. So for example, the item team, the team responsible for the item system, might send out some of its members to the shipping team, and that way those members in the shipping team could work on the item system to make it better for the shipping team. So that's a collaboration pattern. It is something that I've actually seen in customers, and it's not really an official DDD pattern. So if you look at the book, it actually doesn't talk about that. However, I think it's not such a bad idea because at the end of the day, it tries to approach architecture by using some organizational means, which is sort of what DDD is about. So if you look at the way the bounded context should behave and how they should collaborate, that is actually something where oftentimes such organizational measurements are taken to deal with the architecture. So this is just another pattern. I would probably argue it's okay, but it's not in the book. And there is something similar if you look at the bounded context. not just the collaboration, but the bounded contexts themselves. So each of these bounded contexts is clearly a domain model. So I can actually go to the source code of shipping, look at it, and figure out that there is a domain model that somehow tackles the shipping problem. And there is another system, the item system, and I can take a look at the code of that system and figure out, and that is, again, clearly a domain model. So this is the existing terrain, obviously, but the problem is that these bounded contexts that are clearly there, they are not modeling a ubiquitous language. So they are no ideal bounded contexts. So why is that? Because, as we mentioned earlier, the item for invoicing is different from the one for shipping. So the system for invoicing doesn't really have the item, so there is actually a part of the ubiquitous language missing. And the item system, well, that system models the item that is really part of many ubiquitous languages. So if we look at the item system now, that system will actually have the information about the laptop concerning the size and the picture that the laptop might have, about the RAM, about the cost of that laptop, and also how heavy it is. So it would include all the information, obviously. And we can now conclude from that the item system probably has a rather complex data model, but it doesn't really make a lot of sense to talk about it because it's there and it already has been created. And it is obviously a centralized data model, so it is something that all of the systems share. And it might be something like a master data system where we have the definitive information about the item stored. So what happened here? Well, basically we tried to come up with a context map of an existing system, and we ended up with some bounded contexts that are clearly there. However, they don't model a ubiquitous language, and that is actually what I would expect, because at the end of the day, what is so unique and special and interesting about domain-driven design is the idea that a bounded context would be a model of a ubiquitous language. And that is why I came up with the term suboptimal bounded context. So it's a boundary within which a model, but not a ubiquitous language, is defined and applicable. So the item system, for example, is the suboptimal bounded context because it has a model. I can actually show you the code for that, but it is not a ubiquitous language because it just models the item, and the item is different in all of these different bounded contexts, so it is not a ubiquitous language. So we started with the context map. We said we want to map the existing terrain, so the existing domain models, but not each of these domain models is a ubiquitous language, so we end up with suboptimal bounded contexts. So this is the first thing that I want to add to the discussion here. I think there is such a thing as a suboptimal bounded context that we just talked about. But maybe we can get more ideas from that bounded context map pattern. So let's talk about transformation. So if we do a transformation, well, we want to have simpler domain models, easier maintainability, because we will then have ideal bounded contexts, but there might be some effort involved. So we need to really change the system and do a lot of changes there. So how are we going to do that? Well, first of all, we need to separate the logic. And we also need to take the data from the item system, and then we have an ideal bounded context. So then we actually get the result that changes or requests are local to that one bounded context. So let's do that. So let's migrate towards those ideal bounded contexts. So the first step would be to, for example, take out the logic for invoicing and put that in a separate bounded context. Build a domain model that would include the necessary information for the item there. I would probably replicate the data then. To me, that seems natural, because then we will be able to handle a request that comes in, even though if it uses information about the item. So we really have some decoupling in place there. So even if we have some functionality that needs data from the item, we would still be able to handle that request locally because all the information is already there. So what would be the alternative? Well, we could still access the item system each time an item is processed. Then we would have a lot of communication with that system. And there is also no way that we can get rid of the item system, which is so large and complex. And we would even have more synchronous communication in there, which is somewhat bad because it's hard to make that reliable, because it's hard to retry it. So let's do that. So our first step is to use the existing bounded context and separate the logic and make it just the invoicing process, separate that one out. That should probably be not that hard to do because, well, you can just make a copy of the original system and then try to delete as much of the order process as possible, so you have the invoicing process plus some leftovers from the order process. Then we will take the item system and replicate the information that is relevant to the invoicing process, so the price and the tax rate, for example. And now, if a request comes in here, it will be handled by that system without any calls to the item system, because all the information is local. So that's great. And we can actually clearly say that there is an advantage here. What about the next step? So the next step would be to make invoicing the master for the price, for example, and do the replication in the other direction. If you have a PowerPoint architecture like I do, that's actually not that hard to do, because all you need to do is you need to do the replication into the other direction. So that's not really that complicated, is it? However, in the real world, that might be complicated. It's hard to say because it might be very different from different systems. So it really depends on how often the price changes and how complex that information is, and so on and so on. So I'm not sure whether this is a complex step. I'm not sure about the payoff, but that really doesn't matter, because you can decide to do that step or not. That is really up to you. So next step would be to now make sure that all the other systems actually access the invoicing system if they want to have some information about the price. So at that point, the item system will have lost the responsibility for price. So what we are doing now is we have some other systems that still talk to the item system, and we are going to, well, remove the price from the item system. Therefore we also need to remove the replication, and we need to make sure that the other systems go to the invoicing system to learn about the price. That step, again, might be complex or not. It depends on how many other systems there are, how easy they are to change, and therefore it's not really clear how large the payoff will be, and it's also not clear how hard it will be to actually do that step. And the following steps are, well, doing the same for other bounded contexts, because the item system might have a lot of dependencies, because it is the master for such a central piece of your system. But because basically everything depends on the item, your whole business depends on it, that might be complex and might be a major challenge. And again, I'm not trying to say this is always the case. It really depends on what you're doing and what your concrete example looks like. However, it might be a major challenge. And at one point, when I did some consulting for a customer, we had a similar case, and I ended up saying, well, you know, we have these idea-bounded contexts that are really, really great. We have these existing systems. Now, which of the existing systems will be left untouched? And basically the answer was none of them. And that means we are really looking at a lot of stuff that has to be migrated. And then we should, well, have some answers to the question, where is the payoff? Are we really going to do that? So the migration might be complex. Coming up with these idea model contexts is already quite hard, but it might be the easiest part of that whole thing. It's probably harder to find the migration steps, and I would argue that each of these steps should provide some value. So if we say, okay, we take over the information from the item system and put it into the invoicing system, and we have the price in there now, that's the first step, there should be an advantage. The advantage is that each request will be handled by that invoicing system without relying on the item system. So that's great. Is it worth the effort? Well, it depends on how much effort that will be. So for each of these steps, you should say, well, this is the effort, this is the effect, and yes, the effort is worth the effect that we get. So how long will a full migration take place? And how many have actually done that successfully? At the start of my career in the 2000s, I did a migration, or I was part of a project that migrated away from a mainframe. And it turned out that only last year or so, the follow-up project of the follow-up project of the follow-up project has completed that task successfully. So the migration that you're looking at might actually take quite a long time. So it is something that will basically take time. And I think that's actually great news, because it means that you can stop or pause if there is no great benefit to be gained there. The problem here is obviously that those legacy systems are actually things that are useful. Otherwise, we would just say, okay, let's trash them. We don't care about them anymore. But they are often even core to the business. So let's go back to the original question: why are we even migrating? Well, if we have a perfect migration, it means that everything works as before. And the business value for that is basically nothing. So it's the same business processes, it's the same stuff that's happening, so there is no value to be gained. So why would a domain expert support it? Because they are interested in the domain logic and how competitive they are. And obviously, if we have the same logic, still there's not a lot to be gained. Well, of course, there are other reasons for migration, and there are other benefits. We do that for a reason, and the reason is it should be that we are solving business problems and not aesthetics. So we should have a clear advantage that payoffs rather in the short term. So the time that you're planning ahead, the things that you can see that are coming down the road, I think you should take those into account and say, okay, we gain a benefit from that. And the good thing about the stepwise migration is that you can end the migration at any point. So, but why are we migrating again? Well, obviously to gain better maintainability, to be able to change the code easier, which obviously only matters if you actually do change the code. So why would you migrate code that is never changed? The reason why I'm asking that question is because I came across a project where actually there was some code that has been around for a very, very long time and was hardly changed. So why would you migrate that? Maybe because it needs to be changed, but it wasn't because it's not changeable. So that's a good explanation. But if that is not the case, if it's just code that is there and there is no need to change it ever, well, then why would you migrate it? Because the benefit would be that you can easier change it, but if you never change the code, then that doesn't really matter. So we would have some diminishing returns. So there might be some parts that we change very frequently, so it's obviously a good idea to migrate those. There might be a few parts that we basically never change. So over the runtime of the migration, we will get less and less returns. So the question is, would it even make sense to do a full migration? So the migration might not even terminate. And I think, again, that's great news, because it actually means that you're not committing yourself to migrating and, invest a lot of money, but you can stop at any time. So for that reason, I think that's good news. So are there alternatives? So one alternative might be to actually build a new bounded context. So migrating to ideal bounded context, as I said, only pays off if you actually do a lot of changes. And some changes actually justify that you build a new bounded context. So because that's really sort of the maximum change that you can have. And there will be a huge payoff then. So let's talk about that in more detail. So let's assume that in our e-commerce system, we want to have some bonus system where we basically say, okay, the customer gets some bonus points, and for each item he or she purchases, and then he or she gets a rebate or other nice goodies. I would argue that might justify a new domain model. And for me, the interesting question is, where would you store the business bonus points of a customer? So that doesn't really fit into invoicing. That doesn't really fit into the order processing. So I would argue that's probably something that justifies a new bounded context. And you need to, manage those bonus points for the items also somewhere. So that is also probably something that doesn't really fit in one of the existing ones. So we built a bonus system. So we have the item system, which is the old system that keeps track of the items. We have the bonus system here. And in there is obviously items again, because we want to store the bonus points somewhere. Now, would we replicate that information from the item system? Well, it's probably not there because it's a new functionality. So all the discussion that we had about how you would migrate data and so on, it's probably not that complicated here, or not even relevant. So the advantage here is that you get direct business value. There is a bonus system now, so it's very clear that there is a value here. So it provides a lot of value. So you get more support by domain expert. You can now get to a domain expert and talk to him or her about how that bonus system should work, because they expect some revenue from it. It's quite different from trying to migrate the existing system, because they would just say, well, build it the way that it works now. And if you insist on it, if you talk about it, and they will tell you, well, you have the code for the old system, just build it that way. And I think that's sort of a bad situation to be in, because there's obviously not a lot of support, but you really do need this support by the domain experts. There's also less impact, because the old systems, well, they don't have that functionality. So there is more value and less effort. But at the same time, it's sort of cheating, because really you're not migrating anything. So is that even a migration? I'm not sure. If you do that for too long, you're not really solving the original problem, which is that the old system is not really that maintainable anymore. But you will end up with integration of old and new systems, and you will end up with something where we have a hybrid architecture, because it's not really domain-driven design. And I wouldn't call it domain-driven design, because the migration might take so very long, or it might even take forever. So I would rather call it a hybrid architecture, to say, okay, we have some parts that are really domain-driven design, bounded context style, ideal bounded context, and we still have the other old stuff around there. So hybrid architecture would basically say that ideal bounded context and suboptimal bounded context coexist. And I think that communicates the goals better and also sets the expectation better. It doesn't really say we are going to migrate that, and at one point the old system will be away. We are rather saying, well, the old system will probably be there for quite a long time, and we therefore clearly say that we are only migrating and touching those points where idea-bounded contexts actually provide a benefit. So obviously that doesn't really give you great aesthetics. So it's not one common way of putting everything in place, but it's an economic way of doing it because you're investing resources where it makes sense. And it's also less risky because you're not changing the whole system at one point. Now, one of the criticisms that I had about this idea is that, well, it's just sugarcoating an architectural mess. And I can relate to that because obviously you will end up with a system where a lot of bits and pieces really don't, well, work together and where things are often very suboptimal. However, I tend to think about it differently because what this basically means is you can improve your architecture because you can justify improvements. Basically what I'm saying here is, okay, we want to do some migration. We want to do this step to improve the architecture. In this case, we want to build up an idea-bounded context. And we can clearly say why we are doing that. We are doing that because the following stuff down the road becomes easier. So it's justifiable, and we don't need to go to the manager and tell the manager, well, you know, I need this huge pile of money to invest into the quality. We can actually say, well, this is the way we are going to do it. It's a very good way, and you will get better results. So why wouldn't you do it? So there is no excuse anymore. There's no way that you can say, well, there is the existing architecture that's bad, but we have to accept it. Instead, you have to think about it, and you have to take concrete steps to improve the architecture stepwise with concrete steps that actually somehow make stuff better and improve things. And of course, that's also harder than just saying, okay, we're going to do DDD or microservices or whatever, because it actually says, well, you have to say, we are going to do this in that place for that reason. And that's a completely different discussion where you have to think more about what you're doing, why you're doing it, and where you have to think about business codes and so on. So in conclusion, there are several things that I tried to talk about. First of all, aggregates are supposed to be consistent, not bounded context. So replication should basically be fine because we have that data and each part of the data basically belongs to one bounded context. In some cases, there might be some data that is shared across bounded context, but that should be fine. If you try to come up with a context map, you will have existing bounded context, and you will have collaborations that are not present in the original DDD book, and you will have some suboptimal bounded contexts that actually have a domain model but are not modeling a ubiquitous language. If you try to migrate a system towards idea-bounded context, I'm not sure whether the full migration is actually worth it. So probably you will have ideal and suboptimal bounded contexts together. So you will have a hybrid architecture, and that means that you have to justify each change. And I think that's a very good thing because I think architects, developers have to justify what they're doing. So expect that, leverage that, and this is, I think, an interesting approach to take up what you're doing and improve it. If you found that presentation useful, you can send an email to dddexperts2020@ewolff.com, and you will get a link to the Dropbox that includes the slides, all the free booklets that I talked about, and sample chapters from the other books. This is powered by Amazon Lambda, and it's actually a small microservice, so your email address will be locked for 14 days. And if you did some mistakes in the address, I will handle them manually. So that is my data privacy. Thanks a lot for listening, and thanks a lot for spending the attention. Thanks.